Serial communication is not talking about your breakfast cereal. Instead, here what it's talking about is a means of communication between two digital devices in which bits are sent consecutively, one after another, over a single or more than one pin. That's in contrast to parallel digital communications where you'd use a lot of different pins to send a lot of data at once. Now, when I'm connecting my Arduino to my computer, I do that over USB, which in fact stands for Universal Serial Bus, because that is the method of communication that's being used, is a serial method of communication. This is what that communication actually looks like. I'm going to have a series of ones and zeros that are conveying my information. So I might have something like plus 5 volts and 0 volts or ground that I'm switching between to indicate my high and my low, or my ones and my zeros. Usually a serial packet is going to include some number of bits of information along with some control information or overhead information. So in this case, I am normally at high, and when I want to say I'm starting to send a packet, I send a start bit. And then in this case, I follow that with a 0, a 1, 2 zeros, 3 ones, and a 0. So I have a full byte, or 8 bits of information, and that is followed by a stop bit that brings me up to that high level. Right, so in this case, it's taking me 10 actual bits to send 8 bits of information. Of course, there's a lot of varieties of this that we don't really need to get into. I can add more than one stop bit. I can add a parity bit that allows me to check my data. It tells me how many, if I have an even or an odd number of ones in my packet here. So there are a lot of different variations on serial, but for the most part, you don't need to worry about that. What you do need to worry about is the serial rate, or the rate at which I'm sending those bits. So serial rate is often referred to as baud, which in our case is going to be equal to bits per second. Right? But officially it's symbols per second, but in everything that we're going to do, bits is perfectly fine. So a very typical baud rate that I might use is something like 9600 baud, or bits per second, which I'm going to abbreviate BPS. And what this is telling me is that one bit will take approximately 100 microseconds to send. So if I wanted to send that 8 bits of information, 10 bits total in that packet that I showed you earlier, it would take about a millisecond to send, or 10 bits times 100 microseconds per bit. Now I can do faster rates as well. If I really want to speed things up, I can go to 19200 BPS, and that gives me about 50 microseconds per bit. And if you really want to be exceptional, you can send data at 115,200 bits per second, which ends up being about 8.7 microseconds per bit. Now, that ends up being a little unstable. The data isn't always perfectly communicated, so if you really want kind of stable communication, everything's getting there as you expect it to, 9600 or 19200 are pretty reasonable numbers to use in your serial communication with your Arduino. But really what I want to focus on is talking about the serial library for your Arduino. So if you go to your Arduino reference and scroll all the way down, or search for serial, you'll find a whole bunch of functions. So a library is a collection of functions that are related in some way. So all of these are related to serial communication. So I have things like begin, which will be important, available might end up being important. Find is a really nice way to kind of wait for a particular sequence of bits or a particular set of characters to arrive. So there are a lot of interesting functions that we're going to look at, and we're going to look at that in code. Okay, so I'm going to go to that reference page, and I'm going to start with begin. It sounds like a good place to start. All right, and this gives me a description of what this function does, and really primarily what it's doing is setting the data rate that I'm going to start at. It also, it turns out, basically means that pins 0 and 1 on my Arduino, which are labeled TX and RX, are now going to be used for serial communication. So in this case, we see the baud rates that we talked about in the previous slide, 9600 baud, 19200, all the way up to 115,200. And the syntax is just going to be serial.begin. This is a little different. Right now this is that kind of library or class and a function as part of that. So serial.begin, and I provide speed as an argument. And my speed is going to be one of these numbers. I can also have these extra configuration bits, and that does all the things that we talked about earlier. I can add more stop bits, I can add a parity or error correcting bit. Right? There's a lot of different things, but sending 8 bits, no parity bit, and 1 stop bit, or exactly as we drew the packet up before, 10 bits for 8 bits of information is the default. So let's go ahead and put this into a sketch. I'm going to type out serial.begin and provide 9600 baud as the speed I'm going to use. And now I actually want to do something over my serial port, so let's go back to my reference page. And if I scroll down, I see some interesting things here. I want to print some information over my serial port. So I see commands print, I see function print line, I see write. Print and print line are primarily what you're going to use. Write is going to deal with ones and zeros, which is not so readable for you and I. Print and print line are going to allow me to send human readable things. So if I send 10, it's going to send a character 1 and a character 0. If I send ABC, it'll send an ABC. If I send hello world, it should write hello world. Print line is also going to add a new line at the end of that line. So print is not going to add the new line, and a new line is just like hitting enter on your keyboard. It goes down to the next line. Print will not do that. So if I go back to my code, I'm going to just then write serial.println, and I am actually going to write the real hello world now and see what happens. So I'm going to compile that and then upload it to my Arduino. Remember, this code, even though I'm using this serial port, is going to run on my Arduino. And it's done uploading and nothing really happens. It's a little boring. So let's see what's actually going on the Arduino. So the best way to do that is go over here and click on this serial monitor. And voila, hello world pops up. Now you might see something a little garbled popped up at first, so you can just hit that reset button on your Arduino. And as soon as you release that, the program should start again and it prints hello world. So I can go back to this. If I want to print hello world over and over and over and really just make you sick of printing hello world, I can cut that from the setup. And notice I had not put any code in loop. I don't need to put code there, right? I just often do put code in there. So in this case, I'm going to put my serial.println in loop, so that'll basically print that over and over and over again. So once again, I'm going to upload, and now I'm going to look at that on serial monitor again, and yes, it is continually printing a lot of hello worlds. You can see it auto scrolls, so it continues to print that thing, 9600 baud still. Alright, let's see what happens if we take away that ln here. So in this case, I'm going to upload again. It's done uploading, so I can click on serial monitor, and now it's just writing all of that on the same line. And you can see it says no line ending, it's just continuing to write that. Okay, let's go back to my print line, and let's say for whatever reason that was not fast enough for me, and I want to go even faster. So I'm going to send my data at 19,200 baud, or 19,200 bits per second. I'll upload, right, and open the serial monitor. And now it definitely looks like gibberish, right? And what I realize here is I have 9600 baud selected. So my Arduino thinks it's sending at 19,200 bits per second, and it is sending at 19,200 bits per second, but my laptop is only reading it at 9600 baud, which basically makes no sense. So I can select 19200 here. I don't even need to reset my Arduino, and it starts printing properly again. So this is always an important thing to look at. Okay, now I'm going to do something a little more interesting. So I have my Arduino connected up here. I have pins 2 and 4 connected to some power and ground connectors right over here. So I think pin 2 currently is connected to ground, and pin 4 is currently connected to 5 volts. So what I want to do is set up pins 2 and 4 as inputs, and then I want to collect the data from those inputs and send that over the serial port. And so the way I'm actually going to do that is I'm going to print what I read from input 2. I'm going to add a comma after that, right? And notice there's no new line after this. And then I'm going to print line what I read from input 4, from pin 4, and I'm going to add a new line after that. And then I've added this delay function here as well, so this is going to delay a second each time before it continues going through the loop so that I can actually see what I'm doing here. And I left the hello world in, but I can also just take that out. So I'm going to upload this. It's done uploading, so I'll go to the serial monitor. Right, and I see that that pin 2, which was the first one I was printing, is 0. As expected, it was connected to ground. And pin 4 is a 1 because that was connected to 5 volts. So if I reconnect that pin 4 to ground now, I see that that changes to 0. If I instead connect pin 2 to 5 volts, that should change to 1. And so you can see I now have pin 2 is connected to 5 volts and pin 4 is connected to ground, and I'm printing that data over the serial monitor. And so the nice thing about this is that I can read this from the computer and then interpret data. And this may be sensor data, maybe button data, or switch data. Anyway, it's data that I'm interested in and I'm reading on my Arduino.